morning everyone. Welcome back to grade 5 mathematics class. How are you all doing today? We have been learning about patterns and symmetry. Today, let's learn how we can turn or rotate shapes and also about rotational symmetry. But before that, let's revise what is reflection symmetry. Reflection symmetry or line symmetry or mirror symmetry means that an object or shape can be folded or divided along a line into identical halves or mirror images, and each of these two parts will be the reflection of each other. See these examples? You can see the picture of a butterfly here, and there you can see there is a line which can divide this picture into equal halves or mirror images, and this part will be the reflection of this part. And here the square, you can see different lines passing through the square which can divide the square into identical halves or mirror images, and each half will be the reflection of the other half. And these lines which can divide the object or the image into identical halves are called lines of symmetry. Here in this picture, you can see one line of symmetry, whereas in this picture, you can see 4 lines of symmetry. So it's possible that the same picture or object, same image or an object can have more than one line of symmetry. So that was reflection symmetry. Now, what is rotational symmetry? You might have played with a pinwheel or a fidget spinner. See the spin wheel here. You can see the image of a pinwheel, and it has got an axis passing through its center, or it has a fixed point at the center. And this pinwheel rotates about this fixed point, or it spins on its own axis, right? And look at this picture, and when this pinwheel rotates or turns about this fixed point at an angle, at a certain angle, this picture will look exactly the same as before. See, if this is point number 1, if it rotates or turns through an angle, if it comes to this place, this leaf will go up and this picture will look exactly the same. Agree? Now what about this fidget spinner here? How do you play with it? You just hold it here, a center point, and you just turn it around. You rotate it, keeping your fingers at the center. So this fidget spinner rotates about this center point, right? And you are rotating it either this way or this way. When it goes to a certain angle, it will look exactly as this first picture. And when you keep turning it around, at certain times, at certain points, it will look exactly like the first image. Or it will look exactly the same way like it looked in the first position. See, I've got a cube here. And what shape do you see here? You see a square from that side? See, I'm going to insert my finger here. Let this be an axis, and I'm going to rotate this cube. See, does it look the same? No. You see a square now? No. I keep turning it, and now you see the square again. So when it went through an angle, when it turned through an angle, at one point you saw the same image itself, like the image you saw in the beginning. I keep turning it. Now it looks different, but I keep turning it, and now it looks the same. You see the square again. So you see, you can rotate an object or image about a fixed point or on its own axis, and the rotated image can still look the same as that of the first image. That's called rotational symmetry. We'll see one more example. You see this beautiful Rangoli design here. You are turning this about this center point. Will it look the same? When you turn it around, many times you'll see it will look exactly the same as that of the first image. So that is also an example of rotational symmetry. So how would you define rotational symmetry? Rotational symmetry means when an image or an object can be rotated on its own axis or about a fixed point, and the rotated image looks exactly the same as that of the original image. Yeah? Now let's see more about turning shapes. Look at this figure here. See the first image? This looks like a tile. Like the designed tiles that you see on the floors and on walls. You see, I'm turning this tile towards the right, like this. Does it look the same? It looks similar, but not the same. See how the designs have changed their position? We are rotating this tile about this fixed center point, like this. I'm turning this about this fixed point again, and I get this. I turn it again, and I get this. Again, I'm turning it. Now, this image looks exactly the same as the first image. So, after a few rotations or after a few turns, the final picture or the final design looks exactly the same as that of the first image. So, this way, you can turn different shapes and designs to make beautiful patterns. Now, see how many rotations or how many turns were needed for this image to come back to its original shape? See, we turned this image 1, 2, 3, 4 times. So, after 4 turns, it looked the same as the first image. So, there were a total of 4 turns, and hence each turn would be a 1/4 turn. So, here it has gone through a 1/4 turn. So, here again when it reached here, it went through 2 1/4 turns. A 1/4 turn is also called a quarter turn. So, when it goes through 2 quarter turns, what happens? 2 times quarter turns, 2 times 1/4 turns, and that is equal to 1/2. So, that's called a half turn. So, here it was a quarter turn, and when it went through 2 quarter turns, now it has gone through a half turn. And after 4 turns, it looked exactly the same as that of the first image. So, that's called a full turn. So, when an object or an image is turned through an angle of 360 degree, it will look the same as that of the first image. So, there we have the quarter turn, a half turn and a full turn. There are some designs which look exactly the same as that of the first image even after a quarter turn. And there are images or objects which look the same after a half turn. And there are objects or images which look the same only after a full turn. So, here you have one example. See this design here. So, after a quarter turn, it looks exactly the same. And after a half turn, it still looks the same. Now, here you can see the letter N. So, after a quarter turn or a 1/4 turn, it looks like this. It again goes through a quarter turn. So, now it has gone through a half turn. Now, the half turned image looks exactly the same as that of the first image. When it keeps turning, when you keep rotating it, and after a full turn, it looks exactly the same as that of the first image. So, the letter N looks the same after a half turn or 1/2 turn and after a full turn. Now, see the picture of a fan here. It has got 3 leaves. Now, can you tell me how many times this image will look exactly the same when you rotate it, when you turn it about a fixed point? See, what if this is leaf 1 and I'm turning it about this fixed center point, and now this leaf comes here, and now the leaf number 1 is here. Does it look the same? Yes, it will look the same. And keep turning it, and now leaf number 1 is here and the other 2 leaves are here. Then also the fan will look the same. Again, when it comes back to its initial position or when it has completed one full turn, it will look the same. So, this picture will look the same exactly 3 times as it goes through a course of one full rotation. So, how many times this image looked the same as that of the first image when it went through one full rotation? It looked exactly the same 3 times when it completed one full turn. So, the number of times an image will look exactly the same as that of the first image when it rotates about a fixed point or an axis. That number, then at that number of times, is called the order of rotational symmetry. And here, for the image to look the same, how many turns were there? 3 turns were there. And each turn, which made the image look the same, each turn was a 1/3 turn. Clear? You keep this in your mind. Look at this picture here. You can see a 6-pointed star here. Now, what if we are rotating this star about a fixed point? Let it be the center. You are rotating this star about this fixed point, and will it look the same? How many times it will look the same? Let this point be point number 1, and I am going to rotate it this way. So I am rotating it, and now point 1 is here. Now will it look the same? Yes, it will look the same. I keep turning it, now point 1 is here. Will the image look the same? Yes, the image will look the same. And now I keep rotating it, and now point 1 is here. Keep rotating it, point 1 is here, now here, and finally after a full turn, point 1 has come back to its initial position. Can you tell me how many times the image of the star looked exactly the same while it went through a full rotation about this fixed point? It looked exactly the same 6 times. 1, 2, 3, 4, 5, 6. So for a full turn, there were a total of 6 turns, and at 6 number of times, it looked exactly the same. So each turn which made the star looked exactly the same as that of the first image, that each turn was a 1/6 turn. So when it goes through 2 1/6 turns, it is 2 into 1/6, and that is equal to a 1/3 turn. It looked the same after 2 1/6 turns. So you can say a 1/6 turn is equal to a 1/3 turn in this case. So children, I hope this is clear to you. Today we have learned about turning, shapes and designs, and also about rotational symmetry. And what is rotational symmetry? Rotational symmetry means that an object or an image can be rotated about a fixed point or its own axis, and the rotated image looks exactly the same as that of the original image. That's called rotational symmetry. Hope this is clear to you. Now, you have to go through the topic turning shapes, which is in page number 121 and 122 of your textbook. Then you have to move on to exercise 7.3, which is in 122. You have to work out the 4 questions given there. So that's all for today, children. We'll meet in the next class with a new topic. Till then, bye.